Welcome, physical science students, to the next unit in our physical science chemistry quarter. Today we're going to start talking about balancing chemical equations. This whole unit is going to be on chemical bonding. So how we took the atoms that we learned about in the first unit and bond them together, combine them, and make new compounds and that sort of things. This is one of my favorite things to do, mostly because it's math-based. So sorry for all you people that hate math. We are going to be doing a little bit of math for this video and for these assignments. Trust me though, it's just simple addition and trying to figure things out, guessing and checking here and there. But let's get right into it. All right, so let's begin. What is a chemical equation? So a chemical equation describes a chemical change of some kind. Okay, we're gonna, excuse me, we're gonna have two different chemicals or two different compounds combining to make other ones or something new through this chemical process. And so we're gonna have two different parts to an equation. The reactant side, the things that are reacting together, and the product sides, the things that are produced at the end. So for example, I have this here as an example, 2 atoms of silver, couldn't think there for a second, plus this is hydrogen sulfide, okay, react together to make silver sulfide plus hydrogen gas. Okay, so this is just an example of what we're getting into as far as chemistry goes. For this quarter. This is by far a much more interesting, in my opinion, than the history of the atom and all that stuff. This is where we're getting into actual reactions and actual application of the atom and how things interact with each other. Okay, so this reaction symbol is basically a big equal sign, so you can think of it as an equal sign. Of adding these two together equaling something else. All right, so let's start with reactants and products. The reactants are the chemicals you start with before the reaction, written on the left side of the equation, and the product, the new chemicals formed by the reaction, is the stuff written on the right side of the equation. So now we need to go into what those numbers in front of those symbols mean. You notice there were some 2's and there were some subscripts and coefficients. So subscript, they show how many atoms of an element are in a molecule. Those are the ones that are at the bottom. Okay, so if I have like hydrogen and a little 2 down here, okay, that is what we call a subscript. Okay, so that's telling me that I have 2 hydrogen atoms in that molecule. Okay, there is an atom of, or a molecule of water as an example. Okay, 2 atoms of hydrogen, 1 atom of oxygen. Notice that we don't write the 1 subscript, we just assume that there is just 1. Okay, coefficients do similar things. However, they show how many molecules they are of a particular chemical. So subscripts go with atoms, coefficients go with molecules. So for example, when I have 3 H2O, that means I have 3 water molecules, meaning that for every water molecule, there's 2 hydrogen. So for me, for example, on that last slide, we would have had 3 water molecules, meaning we would have 6 hydrogen and 3 oxygen. Okay, so they get multiplied together. Okay, so just to give you a visual of how a chemical reaction happens. Okay, so here we have 2 hydrogen 2s and 1 oxygen 2, and they're going to collide and form 2 water molecules. Okay, what I want you to notice is how they are balanced on each side. So I have 4 hydrogens on the left, 4 hydrogens on the right, 2 oxygens on the left, and 2 oxygens on the right. That has to be true all the time. Okay, we cannot be unbalanced and still work. Okay. That is because of this rule, the law of conservation of mass, meaning that in chemistry, in a chemical reaction, okay, that's a shortened version. If you ever see me write that, it means chemical reaction. Matter is neither matter is neither created nor destroyed, meaning I can't go with having 6 oxygens and then all of a sudden in the products I lose 3 oxygens. Okay, oxygens do not just disappear. Okay, we can't create and we cannot destroy mass. Okay, in other words, the numbers and the types of atoms going into a reaction must be the same as the number and type of atoms coming out. So if I put 2 hydrogens in, I better get 2 hydrogens out. Okay, if an equation obeys the law of conservation, it is what we consider balanced. Balanced. Okay, very important word there, balanced. Okay, so an unbalanced equation. So for example, we have CH4 here, methane gas, plus O2, which is just oxygen, T equals CO2, carbon dioxide, and H2O, water. Okay, so on the left, we have 1 carbon atom, 4 hydrogens, and 2 oxygen atoms. Okay, on the right side, okay, we have 1 carbon atom, 2 hydrogen atoms, and 3 oxygen atoms. So this is an unbalanced equation. We need to come up with coefficients that will balance this equation. Okay, so in order to do that, we place a 2 in front of this O2, making it 4 oxygen atoms on the left. And then we place a 2 in front of this one, making it 4 hydrogen atoms and 2 oxygens. And now life is good, we're balanced, and we have satisfied the law of conservation of mass. All right, so with anything like this, obviously there's rules that we have to abide by, things that we can do, things that we can't do. Number 1, matter cannot be created or destroyed. So that whole balancing thing is rule number 1, the most important thing that we need to be able to do to balance equations. Rule number 2, subscripts cannot be added, removed, or changed. You cannot just take an H2, okay, a hydrogen 2 atom, and just make it a hydrogen 3 atom. Okay, that is a no-no. Okay, they have to be the compound that we said they are. So for example, I can't say, oh my gosh, my pen only kind of works. Let's say I have normal water. In order to balance the equation, I can't just be like, oh, well, I need 1 more hydrogen on this side and make it H3O. You cannot do that. Bad. That is incredibly wrong. Okay, H3O is a completely different compound than H2O. Okay, it is not the same thing as water. Okay, they have to be the same compounds. The only thing I can do is put a coefficient in front of water in order to balance it, which is what number 3 is. You can only change coefficients. So the numbers in front are the only thing that we can change. Coefficients can only go in front of chemical formulas, never in the middle of a formula. So also on those same lines as I was talking about with H2O, I can also not do this. Let's say I have H2O and I need another oxygen, but I don't want to change my number of hydrogens. I cannot say, oh, well, I'm just going to go H2O. No, please don't. That is so bad. Don't do that. Okay, coefficients have to go at the front. That's literally their definition. Okay, few extra tips. Okay, try balancing big formulas first. Save free elements for last, meaning like figure out which ones you have the most of first. Okay, those ones that you have few of, you can figure out at the end. Yeah. Okay, so big formula. Actually, by that I mean big formulas like If you're just adding, let's say, oxygen to something, figure out oxygen at the end. Figure out the big formulas first. Like if you have a compound of hydrogen sulfide or some kind of acid, figure out those ones first and then the other ones later. If the same polyatomic ion appears on both sides of the equation, it's it's usually okay to treat it as one unit. Okay, so what I mean by that is we're going to have some equations that tend to show up a lot. So for example, a sulfate, whether it's a hydrogen sulfate or a silver sulfate or whatever it is, sulfate in general is always SO4. And so what you'll see is that these come in parentheses, and instead of treating this always as one sulfate, oh my gosh, my pen sucks, one sulfate or one sulfur and 4 oxygen all the time, if those things are in parentheses together, just treat them as one atom. Okay, so treat them as one thing that is going to have a coefficient in front of it or that sort of thing. Don't always split it up. Okay, it goes for those. And again, we'll talk about what these are more when we start talking about naming things and more chemical bonding. But just so that you know, hydroxides, sulfates, all those kinds of things will have their own formulas that show up over and over again. Go off that. Hey, there's no one particular way to balance an equation. Some equations are harder to balance than others and might require some creativity to solve. Okay, meaning I'm going to show you how I do some things. If you have a better way that you like, go for it. I'm not going to tell you that my way is perfect and that you should always do it my way. Okay, this is a big math problem that can be approached in several different ways. Okay, now there's typically one answer that's correct and other answers that are not correct. So we do have to come to the same agreement, but the method can be different. All right, so let's balance some equations. So balance the following equation by adjusting coefficients. If you want to, pause the video, try it out on your own, or just keep watching and I can show you an example and maybe you'll try out the next one. So you'll notice I have on the left, I've got 2 nitrogens and 2 hydrogens, but on the right I have 1 nitrogen and 3 hydrogens. So I need to figure out a way to get these numbers to be the same. Okay, now what I'm going to start with, notice that I have 1 nitrogen and 2 nitrogens over there. If I just put a coefficient of 2 there, I now have, instead of 1, I now have 2 nitrogens, but instead of 3 hydrogens, I now have 6. Hey, which is an easy fix because then I look over and I have 2 hydrogens, and if I just put a 3 right there, that's going to change that from a 2 to a 6, and I am now balanced and done. Okay, that is all you guys have to do. You just have to come up with coefficients that make sure that the reactant side equals the product side, and that is it. Okay, now, this one was a simple example. They do get more complicated, as we'll see in the future, but that is the gist of what you're going to have to be able to do. Okay, and I have these already listed out. Cool, I did these by hand. Perfect. Okay, balance the following equation. Again, if you want to pause to try them out, go for it. We're just going to go right back into it. So I have 1 potassium. Okay, let's do this. I already have them listed out. So I've got potassium, chlorine, and oxygen. 1 potassium on the left, 1 chlorine on the left, 3 oxygen on the left. And then if I do the products, I have 1 on the right, 1 on the right for chlorine, but I have 2 oxygens on the right for oxygen, or 2 oxygens on the right for the products. So I'm going to have to figure out a way to get this 3 and 2 to be the same. So if you imagine, the way that I like to think about it is, what do those two things multiply to? They multiply to 6. That would mean adding a 3 over there and a 2 over there. Okay, now obviously that changes my numbers a little bit, which is okay. My computer's freaking out. One second. There we are. Okay, so if I do that, changes my numbers. Now I have 2 potassium on the left, 2 chlorine on the left, 6 oxygen on the left, and 6 oxygen on the right. Okay, and so I only have to clear up one more thing to get these potassium and chlorine to equal the right side. I need to add another 2 in there, which I do, and I finally get what I need and them to be balanced. Okay, and here's an example of what that looks like. All right, this is going to be our last example. Okay, balance the following equation. So we have C2H6 plus O2, and that is going to break down into carbon dioxide and water. And in fact, this chemical equation is actually the combustion of ethane gas. C2H6 is ethane gas. Adding oxygen basically to burn it will create carbon dioxide and water. We'll talk more about these kind of reactions later because combustion reactions are very, very common, very, very popular. So let's see. Okay, so if you did this one correctly, hey, I didn't take you through it, but you should get a 2 C2H6 7O2. I'm just going to double check my answer here. Okay, so if you look, I have 2 times 2 for carbon, so that means 4 carbon. 2 times H6, that's 12 H's. I've got 7 O2, so that's 14 oxygens. And if I'm correct, it should be the exact same on the same other side. So 4 carbon right there. 4 times 2 oxygen right there is 8. But then I also have 6 times that one. Oh wait, let me not do oxygen. Let me do hydrogen next. 6 times 2 there. I've got 12 hydrogen. I just want to keep it consistent as the left. And then finally I have that 4 times this 2 is 8 oxygen there, plus this 6 times this oxygen is 6 more oxygen, which is a total of 14 oxygen. It's balanced and I am good to go. As always, if you have questions, make sure you reach out. If you're having trouble with the math, just pop into office hours or set up a time with me. I can help you with the math. I can help you with the science. All of it. We'll get it squared away. And we'll move on to ionic and covalent bonding in my next video. And we will be on our way. Well, thanks for watching.